Start talking and I loosen things up there. I would think those should take you, hopefully, 15 seconds each. Yeah. Maybe dividing 120 by 15 takes a minute, but everything. Hello. Let's see, Maddie. Let's get her in here too. All right. All right, I'm going to jump in here. If you were looking at our text, for instance, maybe even some of the other videos in Mom, they might refer to these problems, this type of problem or level of problem as solving one-step equations. There's basically one final step, an add or subtract or a multiply or divide that you need to do in order to solve these equations. So that's what we were trying to go over yesterday. This one, follow along, and if you get lost, in the interest of moving along here, okay? I want to isolate, get the x alone, have an extra 33 added, so I want to subtract that 33 from both sides. This doesn't make sense to you, always jump in here. So that kind of cancels that out, plus minus, right? And so what is that, 7, 8? I think that leaves an 8 there, okay? And let's see, this one, okay, so that was really my 2.1 example. Multiply or divide, I think here for these others are stuff in 2.2. And here I have negative 15 times the x. I want to get down to just one of those. Trying to think of things I recall in the past. It's not like you can subtract 15 or you can't subtract 14 x's. That's it, right? Or can't add 14 x's or something like that to leave only one, because then you put it on the other side, right? Because you're doing it to both sides. So what you have to do is divide here. So we're going to divide by that value of negative 15. And I'm showing bad form by not actually writing it in the next line here. Oops. All right, so 1, 2, 3, 4, 5, 6. Is that 8? I think that's also an 8, huh? Counting up my 30s real quick there. 2, 4, 6, 8. All right, here kind of going the other direction. The values.
Wait, sorry, can you back up real quick? How did you get 8 for x for the? Oh, never mind. 1 second. Yeah, hold on.
Okay.
Oh, I just did my division wrong. I apologize.
Yeah, that's okay. I was doing it in my head, so kind of quick there.
Your head's better than the typing on my calculator.
This one, that variable is divided by negative 3, so the opposite operation is to multiply by that negative 3. Okay, and this is like 3 over 1, right? We do that, so those two cancel each other out, and don't lose that negative sign, negative 180. Huh? This one, you could actually do either way. This is negative 1 times x. A negative x is a negative 5. You could almost just say, well, that means positive x is positive 5. You'd be right. I could divide by a negative 1, right? Negative is positive 5. Or really, I could think of it as multiply by negative 1 just because the result turns out to be the same. You get lucky with that one, right? Works either way. Because it's just really flipping the signs, it really is. The opposite of x is -5, so the opposite of the opposite, x is 5. Okay, keep going. Check my admit list there, looks good. Yeah. Look at my notes here. We're going to do more of the messier ones again today as we move on, so don't worry. Here's one of those, not a word problem, a sentence, more like a number word problem rather than an application. Can you write an equation for that? Remember, we kind of tried to break it, look for the equal sign expression, right? Where's the words is equal to, or just is, or we saw, application was, just the verb past tense version. So here's your equal sign. I'll wait for you. So you want to write the equation. We will be asked to write the equation based on this information and then usually solve it. So not much to do. It's kind of which side of the equal sign is this stuff on? So here's 187 is, and then what expression do you get for this other part of the sentence? The product. That implies a certain operation, right? Product is multiply. So, okay, yeah, that's a chapter written. Multiply -17 and x. -17x. Again, it's totally arbitrary which side we put our variable on. The x's. This is just the way the sentence was structured. So it turned out with the x on that side, doesn't matter. We still want to get that x alone. How about we divide by that -17 right now? Huh? I'm going to do it this way again. Whoops. Go down, Steve. Messy. And so that'll get us x. Positive divided by negative is negative.
-11.
11, right? 17, 17. If you're stacking them up, multiplying, -11, I believe. So I agree. Yeah. Right. 17, 17 gets us one. I multiplied it. -11. Is that okay? So if I jump up to next on the level of this kind of problem here. Nancy, use it. 14 yards of material to make 1/3 of the flag team flags. How much does she need? For the whole team. I abbreviated slightly, I didn't write. For 1/3 of the flag team, you're right, she only made 1/3 of them and used 14 yards. How much does she need for the whole team? Not just 1/3. Question mark, huh? So this one really is more like what we would call an application. It really looks like a couple sentences or a paragraph here. And we want to write an equation and then use it to solve. What are you looking for? How about how much? Right? How much does she need? Trying to write these sentences, I get too fast. Sorry. How much does she need for the whole team instead of just 1/3 of the team? So the amount that she needs for everybody is what we're looking for. You could call it any letter you want. I'm going to say something like this. Here I'm defining a variable, is this process we say. I'm going to choose X to be the total number of yards that she needs. I'm going to use the X. That stands for all the material. Well, in terms of all the material she needs, what does the problem tell us to begin with? She uses 14 to make 1/3. Can you sort of turn that around and say, make a sentence that has that is in there? Like 1/3 of the total is 14. Now I just kind of did that in my own head. See if that makes sense to you. 1/3 of the material she needs is 14. So the equation I would get from that, there, and I just wrote that out and I put the X in there for the total that she needs. So 1/3 of X is 14. Can you kind of think it through and organize it or simplify it a little in your mind? And now we are looking for the whole amount. We multiply by 3. Again, sort of compressed on my board there. And I think that's what 42 she needs. 42 yards. Here's my complete sentence, short as it is, including units, with that one. She needs 42 yards. So, yeah, you might run into something like that near the end of 2.2. All right. Is that okay? May I erase? Or let me know if you need me to wait. We're going to continue on. Sort of mentioned our sections 3 and 4 are really just going to build on the same starting concepts. You know, we're going to either add and subtract or multiply and divide. At that last step, there's various degrees of simplifying and rearranging that we have to do to get to that point. And so 2.3 is entitled Equations with Variables and Constants on Both Sides. Oh, I got to move things around. So sort of a process here. Choose a constant side, constant, and a variable side. All right. Got an equation. We're going to say, I'd like to put all the variables on this side, the left side, and all the constants on the right side, or vice versa. It's totally arbitrary. Sometimes it looks like it's easier to move them one way or the other. Then we're going to, well, first that's just making the choice. Then move constants and variables to their own side, right? Move them around. You'll see, you know, that 5x, that's a variable term, right? It's 5 times x. And so you would leave that on the variable side, right? We're going to move terms by adding or subtracting the terms. Move all the variable terms to one side. Move all the constant terms to the other side. And then I'll just say solve, okay? So how about something like, what this is kind of saying is we're going to have problems now that include a combination of adding and subtracting and multiplying or dividing, okay? We're going to have to do some of each step. Here's a real typical shape. This expression equals -8, includes the variable. Here's a term with the variable in it, and here's a constant term, and this side just has constants. instead, so in terms of choosing which side to move things to, I'd say, well, let's leave all the constants on that side, since the variables are all on this side anyway, and just constants there. So we're going to move all the constants to that side. So what's the extra constant here? This is a separate term, 4. That's a constant value. So I want to get this away from all those x's. So just as though this were 1x, I'm going to subtract this 4 from both sides. Now I have all the variables alone and all the constants alone on opposite sides. Here's one of those, the variables being multiplied. I'm going to divide by that 3. And get that the x value must be -4. That works. So notice I've started talking about, I have separate terms. Some are variable terms and some are constant terms. When you have this kind of situation, it's usually best, gotta say usually, right, to move the, like don't try to divide by 3 right away. That's what I'm getting at. Because then I have to divide the 4 by 3, I have to divide the 8 by 3, I get messy fractions. Usually it's better to leave the variables alone and move the constant terms out of the way first. Just do it again. Board is bouncing today, noisy. The balance a little better. No, that's no better. It's supposed to look like a 5 there. 5x plus 3 equals -37. All right, similar situation. Let's leave the constants there and the variables here. So I need to move this extra constant term. I need to remove it or cancel it out on both sides. Get to a similar situation there. And if I divide both sides by the 5, the 1x is -8. So what I'm doing is a combination of adding or subtracting from both sides and multiplying or dividing on both sides. So both of those kinds of operations, these would be called two-step equations in some texts or something like that. All right, here we go. All right, looking at that, I see, oh, I got variables on both sides, but only constants on this side. So this time I'm going to move the variables all to one side and leave the constants there. Okay. So this is just variables, so I'm going to leave them here. I'm going to do what I need to do to get rid of the x's on this side, which always seems to introduce them on the other side, right? So I'm going to subtract 4 x's from this side. I can still use that vertical kind of process if you like that, as long as I'm kind of neat and careful. So 6 x's minus 4 x's, how many x's left, right? I have 2 x's. And those went away, and so 2 x's is -10. Here I am again, ready to divide to get 1 x. Decisions, decisions, as the saying goes. I've got variables on both sides and I've got constants on both sides. I just need to make a choice. Which side do I want to put what on? And I kind of have a personal preference. Gee, it'd be nice if my variables were positive. Is one number bigger than the other? So if I move it one way, I get positive x's. It totally is arbitrary. But it's like, oh, there's more here than here. So why don't I move them all this way? Because I'm going to subtract these 6 x's. I'll do this in a couple steps. All right. So I'm going to subtract all the x's with the intent of moving them. Any remaining x's will be on the left here. So if I do that, I have 6 x's left. We haven't really done anything to the 8, and there's the 2 still there. All right, got the variables on one side. Now I'm going to move this constant term, remove it from this side by subtracting it from both sides. Real tricky numbers there. Divide by 6. So there was our, move them around because they've got them on both sides kind of problem. Let me put one up there like that and see, wait a couple minutes, see if you figure it out, okay? Here goes.
Can we do one more of those?
That's what I'm saying. I'm going to put one of those up there, but I'm going to wait and see. Let you get that started, okay? Get started.
Thank you.
All right, similar situation. You make the choice. Which way do you want to go? I wait about a minute. Hopefully you're done.
Professor, can I ask you a question?
Yes.
No, this may be a silly question, but say with this problem, I wanted to remove the variables. So, if I remove the 7x from both sides, that'll be easier, right? As opposed to removing the 9x.
That's what I was kind of saying. It really doesn't matter because the signs will always kind of work out to be the same answer. If I subtract the 7, I get 2 x's on this side. If I subtract the 9 x's, I get -2 on this side. So it looks like it's negative, it changed, but that means the constant signs are going to change and it would still turn out to be the same answer. So it's whichever, if this was plus and this was minus, it might not even make a difference. So it's really a choice. It's up to you.
Thank you, sir.
Yep. Just be careful with your operations, right?
Roger that.
How about who's got an answer? 4?
Okay.
Is it 4?
Yeah.
I think I did it in my head quickly, but I think it's 4. So let's go this way, all right? And I think it's safer not to try to do both things at once, right? So I'm going to say 2x plus 4 equals 12. Now I'll move the constants, right? -4. Divide by 2. And hopefully you were all ahead of me there. That work out? Or if you get lost, see if you can tell me how or why. Sometimes you'll see one with a fraction. Hopefully not too messy. Let's see, let's call it. Just modified my own problem. Hopefully I didn't make it too hard. I got a fraction amount of x's, I still got to get all the x's on one side, all the constants on the other side. Looks like I'm liking moving x's to the left a lot. It just happens that way to be in my examples. Doesn't have to. Everybody okay with I'm going to subtract these x's from both sides. Now, I mentioned when dealing with fractions, sometimes that horizontal system is a little better because then you've got fractions side by side. But notice they already had the common denominator. You know, it wasn't too messy. So really, I'm just doing 7 minus 5. 2 6th x plus 11 equals 8. Now, I just wrote that strictly the way it worked out. This can be simplified to 1/3 x. Everybody all right with that? 1/3 x. So I'm going to write it that way at the next step, even though I'm really going to be moving this 11. Subtract 11. 1/3 x equals -3. I'll make sure I didn't lose you there. I just did this. Okay. So here are my variables. You could think of that as divided by 3 or being multiplied by 1/3. So the opposite is to multiply by 3. Lots of 3's there. Right? -9.
So I'm confused by this a little bit. How I see it is back up at the 1/3 x equals -3. Wouldn't you do 1/3 x divided by 1/3 and then -3 divided by 1/3?
How do we divide by a fraction?
By the reciprocal. Oh, okay. Thanks for doing that.
No, I mean, I know I said it yesterday, but I know the first time I say something, it doesn't necessarily register, you know? Yeah, that's a great question. Good. And you know, that it helped to make it click that undoing the fraction, we're going to multiply by its reciprocal. Yeah, canceling out, multiply by the reciprocal. Okay? Good. All right, I'm going to add a step here on my list. I left room up there on purpose. Simplify each side as much as possible. As much as possible. Remember yesterday we did some of those where we had to combine some like terms first or do some distributing first. This really is now what 2.4 is all about. A general strategy, a process that you can use for all of them as they get more mixed up, more complicated. All right. Now, really, there are a couple different ways you could approach this, but I'm going to do it. I'll show you both, talk it through. Because this one you might say is, for one that needs some simplifying, it's a simple version of a simplifying. I'm going to say, let's practice distributing first, all right? I'm going to distribute here. Some of you are already going, but can't you? And yes, you probably can. But 5 times each of those. That was just getting rid of the parentheses. The variable's actually kind of locked inside there. Can't do anything with it. Okay, here's my variable terms. I got an extra added 15, so I'm going to subtract the 15 from both sides. Got me down to that. We've done quite a few of these now. Hope that's, you're getting comfortable with this. Right, multiply or divide.
Can we do another one with fractions? It's still not being very clear to me why, even in the last one, we're going from 2 over 6x and immediately simplifying it. Are we just doing that because that's just the next step that we're just supposed to know we're supposed to do? I mean,
I could have done that whole problem and left it as 2/6, right? I could have kept the fraction just the way it looked, but because that fraction is equivalent or can be reduced to 1/3, that's what I did.
so anytime you're able to just reduce it, you probably should versus going with the original problem. Is that what you're saying?
It made the number smaller to work with, you know?
Mm-hmm.
So I have a preference for that. You could have made it work without it, as long as you were careful.
Okay.
Okay.
Okay, thank you.
Yep. But yeah, we'll try to work in some more fractions. The other thing that I was thinking that maybe some of you are thinking, well, can't I just divide by this 5 right now? Well, you can if you think it's going to be like neat enough. It's kind of like me saying, oh, I don't want to, remember where I said, oh, I don't want to divide by the 3 too soon because then I get fractions, I get messier numbers in my problem. If I divided both sides by 5, well, that works, all right? So this is a factor of 5 times all of this. This is a second way to do it, which works because this is kind of simple. This is one term, right? This is one term built out of 2 factors. Well, if I can divide by one of those factors, then it's clean. That's not too hard. If I had multiple terms, right? If I had 5x plus 7 equals 23, I don't want to divide by 5 because I have to divide every term by 5. And I don't want that mess right now just to get 1x. I'll do that at the end. That's why I'm saying move the constant usually first and divide at the end. But in this case, there's no extra pieces to have to divide by 5. If I'm divided by 5, I have x plus 3 is 7. X equals 4. Hopefully we got the same answer, right? That works in this case just because that's just one term and it doesn't get messy. Stick in the back of your mind if that makes a lot of sense to you. You might use it sometime. Usually I like to distribute just to get rid of all that extra stuff. So mostly I'm going to distribute for these kinds of problems, right? -2 times everything inside, right? Negative times that and negative times that. -8. Subtracting both of those, two times both of those, -8. That's the part people sometimes miss.
Let us do it. Let us try.
Let us do it. You let us think. What'd you get? Not there yet. It's okay.
I got 2.
2, I like it. Any problems, difficulty? Being smart aleck. I should do it though, just to show, right? Hopefully that worked for you. I'm gonna add the 8. Divide by -2. Okay. All right, be that way. What do you think we should do to this one first? How many terms are on the left side of this equation? How many big pieces are on the left side? And so I can see how, well, the things that were messy over there, how many pieces does that count as? This is one term with a couple things multiplied together. It just happens that one of those things is complicated inside. But that's one term, and that's one term. There's only really two, like levels of size, right? On that larger scale, there's only two terms on that side. Unfortunately, I saw this from a couple of you about distributing. This is only saying 7 of these other pieces here in this term. This doesn't distribute to the next term, right? It's not 7 times this and then 7 times the 8 also. This 8 is just good all by itself, separate term. What do you think you would do first here? Any thoughts?
Distribute the 7.
That works. Actually, there's 2 different ways to go about it now that I'm thinking about it, and that's definitely one of them.
Add the 8 to the 15.
The other way I was thinking that came to me first was, oh, let's move the 8 first. And then we've got that thing alone. But if I distribute the 7, well, then I could do some simplifying that way. I'm going to go that way just because he said that, right? And I really wish I could see who you all were when you spoke up like that. But you're kind of all spread out. I'm lucky if I could see 4 of your faces on the top of my screen. You see, I just distributed 7 of that, 7 of that, and then the rest is -8. Oh, well, gee, I could just combine those now, can't I? Like terms. You could finish it up. Right, those are 2 constant terms. They're like terms, no variables. I could combine them. Not sure what the answer turns out to be, but maybe it'll be a fraction. I'll have to divide by 7 at the end, I think. At the end, I would divide by 7. That's what I'm getting at. I'm going to move that 29 now, right? Oh, yeah. I have my signs kind of backwards. If I add 29, I get a nice number over here, don't I? 14? There we go. And I get another 2, huh? This looks a little different. How many terms are on the left side of that equation? Yeah, it's just one messy looking thing. I'd like to point out, this could also have been written as 1/3 times 2x minus 5. See how those 2 are different ways of writing the same thing here? 2x minus 5 divided by 3 is the same as multiplying it by 1/3. Now, if I look at it this way, gosh, that's be really messy. If I tried to distribute the 1/3, right? I'd get fractions. And that would just be distributing here. I wouldn't have to do anything to the 7. Right? I'm just distributing and I would get fractions equals 7. Right? Be nice to avoid that. Here is a situation kind of unlike that very first one where I said, oh, here's a 5. You could either distribute or you could divide. Well, here's a situation similar to that. I would actually prefer to multiply and get rid of the fraction. That's what I would do in this case. Here's my piece with the variable. And it's all being divided by 3. Let's multiply by 3 and get rid of the fraction. Multiply by 3. So here I'm going to rewrite it. Multiplying by 3 just means now I have that on top. There's the 3 I'm multiplying by. Of course, I have to do this side also. That makes sense. I purposely chose that, trying to cancel out this 3. Then I get rid of that fraction.
So do you distribute that 3 then?
Oh, I'm sorry. Say again. I got to turn up my volume.
Do you distribute that 3 to?
No. See, I chose it. I chose to do that so it would cancel back.
Okay, gotcha. Thank you.
Yeah. Oh, yeah. Right. Don't make a mess here. Otherwise, that was the only reason I decided to multiply by 3 was to get rid of the fraction. Now that should look like things we've been doing. Add the 5. So, I keep going. I will keep going. We can just make up all kinds of different variations of the way these add, subtract, multiply, and divide are put together. And so you just kind of have to analyze what's the best first step. Should I add or subtract this piece or multiply or divide by something? We'll do more. Here we go. All right. All right. Got my list here. Stuff. What's the first thing? Again, there's a couple things you could do first. So kind of depends what you see. So let me point out things that it's good for you to recognize. That here are 2 separate terms, right? The 12 is a standalone piece. And there's one of those spots in some of those order of operations problems. I'd say, oh, that's a trap. Don't do 12 minus 3. Right? This is 3 times all of that other stuff. Right? You can't combine the 12 and the 3. They're 2 different kinds of things right now. So here's one term and another term. What do you want to do there? Somebody?
My question is, what the first thing I would do, just looking at this, is I would take the 3 as a -3 and times the -3 by 4 and the -3 by 3.
Distribute. Yes. Okay. Okay.
I'm asking if I should attach that negative to the 3 or just leave it as like a subtraction symbol.
I wrote it that way.
So I need to distribute the -3?
Absolutely.
Okay, thank you.
This is the shortcut way we write this. But yes, the negative is part of what has to go to each of those pieces inside. That's a common mistake pitfall area. Yeah, that negative goes with the 3. Okay, so yeah, let's do that. Okay, 12. Let's see, minus 12x minus 9. That's where it gets you, is that second term there. Minus 9 equals -17. Still some simplifying to be done. You see it? Some like terms over here. The 12 is a constant, the -9 is a constant. I can put those 2 together. 12 minus 9. How about 3 minus 12x? We haven't really done anything to those x's yet. Now, what do you want to do? I think we're kind of at this point. Let's get all the constants on one side and all the variables on the other side. Well, the only variables are already over on this side. I would move the constant. I would subtract this 3 and leave those negative 12x's there. That negative is attached to the 12. Again, you can sort of think of this as, right, 3 plus a negative 12x. So if we get rid of the 3, this negative 12x is still there. Subtract the 3. We're going to get a fraction. Maybe you can see that coming too, huh? Because now I have to divide by the negative 12. And x equals, now that's going to be positive, 20 over 12. And there I'm implying, but we can reduce that. All right, so plan to reduce that. What's your lowest terms for that? You can cut it in half and cut it in half. You see, or you recognize that both of those are divisible by 4. If you cancel a factor of 4, hard to write down low on the board. 5/3, negative, negative, it did mean it turned positive. That's kind of weird. This is messy. What am I doing? A couple minutes left. Do I need to jump to anything? Oh, okay. We will come back and do more of these tomorrow. But I want to talk about another main concept in this section. All right. And some of you have already asked me questions about this. But anyway, we'll get through all the big pieces. And this is 2.4 we've been working on once I start getting all those mixed up messy things. So we're getting through 2.3 and most of 2.4 today. Let's see. All right, 3 different equations here, 3 different situations, 3 different outcomes going to come from this. Here, so maybe watch and take notes. This shouldn't be too weird looking, hopefully. Oh, got that number that's going to work, one answer. Next one. Well, okay, constants and variables on both sides. Maybe right now, I wrote this as a very simple example. They're the same. Let's say I'm going to move all the x's. I subtract the x's from both sides, they go away. -5 equals -5, and there's no more x's. Oh, well, let's get all the constants on the same side. I mean, I could try to add 5 and even get down to 0 equals 0. That's weird. No x's. And that's true. All right. This kind is called an identity. This is identical to that one. And they always sort of hide it. You have to do the work and then, oh, they boil down to the same thing. No variables. It's not dependent on the variable at all. No matter what variable I chose, whatever number I chose for x, it would work out true. So there are an infinite number of solutions. There's my abbreviation for solutions. Infinite number of solutions. Any number would work. What's the deal over here? I know I'm over time. Let's get rid of those x's again. -5 equals 4. Similarly, the x's went away, but there's not true. It's a false statement. This is what happens when there's no solution. This is referred to as a contradiction. Negative connotation to that word, right? No solution, contradiction. So these are 3 classifications. This one, there's one condition that makes it true. It's called conditional. All right, one solution. So this is at the end of 2.4. We'll practice this a little bit more, but in case you were trying to get through that section, I wanted to throw that out there at the end today. So almost got through 2.4. We'll do that in 2.5 tomorrow. We're really on schedule. Please read my notes here, my notes in Mom. I was just trying to be clear. I wasn't really upset yesterday, but when I wrote this thing, I kind of want to make some expectations clear. So check that out. Okay, so I went a couple minutes over time. I should probably stop. So I will see you guys tomorrow. If you, if you're working on homework and get stuck, still send me questions. All right. It's all right. I wasn't saying I don't want to help.
I have a quick question after.
All right. Okay, folks. So, yeah, I'll let you go for today. Feel free. And feel free to check out and we'll pick it up tomorrow. Okay.
Thank you.
Thank you so
Yeah.
much.
See you tomorrow.
Take care.
Bye, everyone. Have a nice day.
Thank you.
Bye, you too. Take care.
Should I erase this, Kayleen? Is it related to this?
Yeah.
Yeah, okay.
Is it okay if I stay?
Yes.
Okay.
That's fine.
Oh. As long as it's not a private question. From
No.
Yeah, okay.
So on the homework I'm kind of ahead again. So for the homework for next week, on 2.1, it says x over -7 equals -3. So would I divide by -1/7?
No.
Or sorry, times -1/7?
Oh, what did I just do to that pen? Is this what you just described? This looks like one of today's problems.
Yeah.
I was gonna say, this looks like this week's stuff. Now, is this a handed homework problem?
Hold on, wait. Well, it's supposed to be. It says it's due next week.
What's that?
2.1.
2.1, we just
Yeah.
covered, and then it's always due the next Monday. It's due Monday.
Yeah.
Yeah, okay, I get it. So this is really like yesterday. This is a division problem. How do it's x is divided by the negative 7. Huh?
Yeah. Multiplication.
Multiplicate, do the opposite of divide by -7, multiply by the -7.
So it's just -7. Do we have to do it to the other side? Yeah, okay. Got it. Got it now. Okay, that makes sense. Cool.
Right? That's a good
Okay,
question.
that's-
If it didn't make sense, it's a good question. Keep practicing.
Yeah, that was my question now.
Was that it for today?
Yeah.
Question as well.
That's good. I'm teasing it, Kaylee. Good. All right. Well, hi, Elizabeth. You got one for yourself also?
Yeah, so I'm working through the 2.3, 2.4 homework, and I keep running into the same problem. I'm able to get pretty much all the way down to like the last step, and then I'll go to divide, and it comes out with like a crazy decimal, and I don't understand what I'm doing wrong. So I was hoping we could work through just one problem.
All right. So, and it wasn't one of those weird ones I just wrote at the end there, was it?
It was a little similar, but it didn't answer my question.
Oh, yeah. Okay. All right.
Give you Is it okay if I give you the question I'm working through, and then can I talk you through it and see what I'm doing wrong?
Yeah. Perfect. Yes.
Okay, so it's 6, and in parentheses, 2x plus 1
Yes.
equal sign 9x plus 1.
I'm sorry. Equal sign. Is that what you said?
Yes,
X plus 1.
9x plus 1.
9x plus 1. Okay.
Yes. So the first thing I would do is 6 times 2x and get 12x. And then 6 times 1 and get 6. So I have 12x plus 6. And then equal 9x plus 1, obviously.
All right. This is
And then I would subtract the 6 and then from the 6 and subtract 6 from the 1. And then that got me, where am I? That gives me -5, right?
yeah.
So 12x equals 9x minus 5.
Yeah, and don't lose all your x's.
Yeah. And then I subtract 9x from 12x and 9x.
Oh yeah, this is gonna have a fraction answer. Don't try to write a decimal.
Yeah, no, I don't know how to I'm stuck on like, so okay, so I divide that by 3, both sides. And then what do I do? Just that, is that my answer? Oh, okay, I was trying to work through that.
Ah,
Okay,
Um,
that makes sense. Thank you.
almost never will we expect you to write a decimal unless we tell you. Okay.
Yeah, and it says do not convert the answer to a decimal. So I was like, okay, what am I doing wrong? But that means I just got the answer and I don't have an extra step. So
There it is, right there.
thank you for spending the time to do that. I really appreciate it.
No problem. No problem.
Have
Yeah,
a good day.
I look forward to your email today later.
Oh yeah, I'll do that right now. Thank you.
No problem. Okay,
Have a
are we
good day.
good today then, folks?
Yep.
All right. See you
Bye.
then. Okay. Have a nice
Bye.
day.
You
You
too.
too. Bye-bye.
Bye.